Welcome to another tech tip. Today we will focus on motor and transducer faults. But not focusing on meter use, rather simple tests that will pinpoint the issue and can speed up the job. So, with that, let's get started and troubleshoot the drive. The key today is not to overthink the issues. Motor and transducer issues are common, but not hard to diagnose. Remember these few tips. If the drive is telling you something, it is often not the drive. What is the opposite reaction of the fault showing? Remember, first and foremost, we are pump people. Motor testing is still the same testing we have been doing all these years. Transducers, on the other hand, either work or do not, and simple testing often works well. Remember safety first. When working within the drive or wired connections, turn the power off. Never assume the drive is powered down. Though the introduction said no meters, we may eventually need to ohm test the motor, for example. Know how your meter works and ensure it is set to read the proper measurement needed. Make sure the probes are connected correctly and in good condition. And use alligator clamps or J-hooks to ensure a firm, hands-free contact. And always work safe, know the regulations and codes, and follow them. Let's start the discussion with motors. This is a typical fault. You may be confronted with overcurrent, lock rotor, cannot start, motor jam. These are all high amp faults. Now, if you have a code or a blinking light situation, refer to the original manufacturer owner's manual and determine the fault and procedure. The IntelliDrive always lists faults in plain language: English, Spanish, or French. First thing I would check is the programming. Now on the screen you see the motor menu. A point to remember is that if you upon initial startup were to hit just enter, you would program single phase, 2-wire, and most importantly 0 amps. And of course, if you do this and start the drive, any motor that is in working condition will of course pull more than 0 amps at start. I also recommend checking the amp setting first step, as you never know what might have happened to the system or if the owner might have changed something unknowingly. To check this setting, unlock the menu if needed. The password is 4 7s. Once unlocked, the first menu you will see is Settings. Scroll down using the arrow key to bring up the motor menu. Press Enter and scroll down, proofing the motor settings. You will first see motor phase, then type of motor. Third thing you will see is the amp setting. Proof this to ensure the setting is correct and save. Using the arrow keys will change position and value, pressing Enter will save. Once the amps are proofed, press the status key to quickly exit to the main screen. Now we proofed the program. The next step with a high amp fault is to turn the drive off and carefully unplug the motor connection shown here. Have the motor plug in a position that it will not contact any part of the drive and restart the drive. Clear the fault and press auto start. Wait. Do you get another high amp fault? Well, if no motor connected and you still see a high amp fault, it is most likely the drive. If you get a low amp fault, well, it is time to test the motor. You may wish to turn off the drive and reconnect the motor. Turn the drive back on and reset and start the drive. Does the high amp fault return? Then it is most likely the motor. A good place to start troubleshooting is proofing the wires, ensuring they are secured tightly into the harness. This is often the case, and simply proofing and tightening the connection can resolve the issue. If is not the wire, well, time to break out the meter. And I know in the beginning we said no meters. Well, let's first look at what we have done. We did no meter testing, simply proofing the programming, checking the wire connections, and isolating the issue. Now the issue is isolated, it is time to do what we have done in our industry for years. Pull out the winding and ground test data for the motor and do the ohm testing you should be familiar with. Notice we are not testing the drive, because the drive did not show a high amp fault without a motor. So yes, you may need to eventually use a meter, but it is not the first step. For motor ohm testing, be sure to view our tech tips on this subject. What if the drive starts with a low amp fault? Well, first, there is no way to create the opposite fault, a high amp fault, safely. So do not attempt to. So, what to do? Well, first remember, if the motor is a 1 horsepower or smaller 3-wire pump, there may be a thermal overload that is tripped and may take up to 15 minutes or so to reset. This is important to remember when measuring ohms while evaluating the windings. Should you not get a reading, wait and remeasure? Also note that any 2-wire motor will have a thermal overload. Just like a high-amp, fault-proof the wire connections and ensure they are tight and secure. Another note about 2-wire connections: the motor wires need to go the yellow and black. Any other combination will cause the unit to fault. Finally, test the motor as discussed earlier. Be sure to review the data from the motor manufacturer information and always work safe, follow all regulations and wear PPE, personal protective equipment. Transducers can be quite simple to test. Think opposites. But before we get into the testing of a transducer, there are some common key points to consider. Was the transducer installed to fail? Who would do such a thing? Many people unknowingly. An example is the use of nylon ties that can pinch and break the delicate wire. Or placement on a metal pipe that might pick up stray voltage. Or in a section of the system that has fittings too close to the transducer and creates water hammer. Best advice: protect the investment. Understand where to properly install the transducer in the system. If installing the transducer on a metal pipe, isolate or insulate the transducer. Often a snubber can achieve this, but check with the manufacturer. Water hammer? A snubber again can protect the investment. A proper installation can mean all the difference. Facing an open transducer, create a safe short. Note: still be cautious, this is DC milliamps, but still be safe. To start, turn off the drive and disconnect the transducer cable, and using a small gauge wire create a jumper to test the wire. Doing this, the drive once turned back on and reset, and assuming the wire is good should read maximum PSI and then quickly fault on transducer short. If this is the case, try replacing the transducer and test run the system. Now, should it not show short, disconnect the transducer wire from the drive input and place a jumper as shown here. Again, upon starting the drive and running, the pressure should show maximum pressure and then fault out to transducer short. If this is the case, replace the transducer wire. Now, if this test still shows as transducer open, the issue is most likely in the drive. And remember, do not replace the transducer in an environment that will allow it to fail again, as discussed earlier. Finally, what about a short transducer fault? Well, again, turn off the drive. Now unplug the transducer wire at the transducer and restart, then reset the drive. Run the drive. Does the fault change to open transducer? If yes, replace the transducer. If not, turn off the drive and remove the transducer wire at the drive. Start, reset, then run the drive. What fault shows? If the short fault condition appears again, the issue would be the drive. If an open fault appears, replace the transducer wire. See no meters. And again, why did the failure happen? Installation can make or break a system. So, to review, do not be intimidated by a drive. These test procedures are straightforward with little need for a meter. Just think opposites, and if the condition remains no matter the test procedure, then yes, the drive can be at fault. Also remember, when it comes to the transducer, was it placed in a position to fail? Hope this gives some light on simple testing of a drive, and see you next tech tip.